Aditi, are you able to hear the voice now? Yes. Just in chat box, you write it down. Are you able to hear the voice? Okay, okay. We'll start this one today. See, till now in your programs, let's just give one. In this one, we have done this one till here, right? Now, alternate LED and ascending order. Have we done this one? Ascending order and alternate LED is responded by using yes or no? No. Okay. Now, so same procedure we have to follow over here. See, and buzzer, relay, switch, we done in the last classes, right? So last lab session we have done, right? 3 programs, something we have done, right? So you can see the record which I have sent you people. The same thing, you don't start writing this all those things. You start from this part. Okay, this is a manual actually. So you don't write all those things. You start from this one. Okay. From here you start writing it, and see this all things should be written. See, this one we learn in the morning class. The same thing we use it here also. This is a block diagram, more elaborated way it has been designed in this one block diagram. Okay, see, I said na something VCC power supply, something I said right in the morning class. Ground. Okay, all ports are here. Okay, reset button is there. Okay, here enable pin I said, right? This is your enable pin. What is address slash enable pin?
Manual is not being shown now.
Which one, ma? Manual is not showing. It is not sharing, ma.
Only the microvision that program screen is being shown.
Okay, okay, just wait, just wait. Manual only I'm showing. Just wait, I'll share it once again. Uh, now you people are able to see this one. Yes, just message it, ma. Yes, okay. Yes, right. Okay. Now see, in this one, you start writing it from this part, ma. Don't write till here. Start from this one. In your observation, in your records, theory you can write 2 sides, but programs you write it in 1 side. Okay, because you had you have to stick something in the right sides. Okay, so cycle 1 you start writing it in this one. Okay, basic in cycle 1 we had na all this basic things we had it. Okay, so we use it 8051 using C compiler. We do all these programs. We are using only 8 bits. Okay, we are using 8-bit. We are not using 32-bit. Okay, 32-bit programs will be used to this traffic controller and stepper motor and elevator. Okay, they are these programs we use it, but in that programs also still I'm using 8-bit only. I'm not using 32-bit controller. I'm using only 8-bit because for two pins to be connected and showing the output. By using that, I'm used this traffic controller, stepper motor and elevator. Okay. See, same thing. See, you people have to install this microkill version 5. It's there available on the yeah, no, yeah, it is freely available on the site. You can just check that. Okay. See, in that one, you'll be having it 5.60 version is there. You just take any version, okay, which is free version is there. You install it, okay. Simply, you just create one folder on the desktop or somewhere. You just create it, okay, and write the program. If first you have to take it. I said already the steps to you all, right? Remember, all of you. Have you people remembered, ma? Know what steps we have done? Yes, in chat box you write it down. I said already explained about the steps. Do people know it? Yes. Okay. No, only 33 is responding. The others are not responding it at all. I don't know. Okay. See, we are just taking the classes to only 33. I think the rest of the people we are not taking classes. Huh? Okay, these are all the features we had, but we are using presently here. Okay, 9. Okay. Now, see, in this one, we are using in this 8051, which microcontroller we are using? We are using 40 pin DIP. Okay, this pin only we are using it. Okay, morning I said, right? DIP, what it is. Now, same thing, you have to write down this one in your lab records also. Okay, this whole thing is there. This from here, this from block diagram to this, all this part comes under in your first unit only. Okay, unit 1 only, it is coming this all data content till here. Registers, special registers, stack, timers, counters, this all comes under your unit 1's part 2. Okay, 8051 architecture is there na. In that one, this all things will come. Okay, mode 1, mode 2, mode 3, interrupt systems. Okay, till here it is there. Okay, so after this we start with the program. See, I have given you a program by explain. I have explained by using this one. Okay, by using this one we did the first program. You had another code also, we had it here. Okay, if you are understanding this one, you use it this. Otherwise, if you are understanding this one, you use it this. Tilt we are using only, and the thing is over here, we are using tilt here, we are not using tilt here. Okay, tilt one button will be there. You just see that in your keyboard. If you are sitting in the front of the keyboard, just you see that above the tab we had it one shift negation, we use it, that we are using it, means it will be understandable for all the switches. That mean is this negation is stands for all the switches. Okay, that it stands for. Okay, now in this one we are not using anything, directly we are writing it on off for every time the switch case is moving on here in this case. Okay, if you are understanding this one, you write down this. Otherwise, if you are understanding this one program, you write down this, or I have mentioned in the between. Okay, you same thing folder I have sent you people in a common mail ID. See, your people have sent me a common mail ID, right? In that I have sent it. Okay, okay, 33 you got this one manual. 9 you got this manual in a common mail ID. Just write it down in a chat box, yes or no. Common mail ID. You have you people only given me, right, one common mail ID. In this one I have sent it. We have received. Okay, okay, okay. So same thing. Okay. Same thing in your relay program also. We are writing two programs here. Just check it out, that which you are understanding one, that you write it down. Okay, we have used this one 456 P2 of 42. In that 456 pin we have used it. Okay, same thing, you have to check it. Okay, simply you install that program. Okay, same thing, create one folder on the desktop or somewhere else. Right, then see, your people are able to see the desktop now. Folder you have to create it. Okay, basic steps you know it, then all the programs of your cycle one is easy for you people. Okay, see, I'm writing it here. 9 you are there, 9 you are there, 27 are you there?
Yes, ma'am.
You able to see that desktop now?
No, ma'am.
No,
It's showing some second program in
second program.
Microsoft Word.
Okay, okay, I'll share it now. Once again, I'll stop sharing it. Okay, I'll just close all the things first. Okay, now I'll share it. Okay, now you have to just create here a folder. I'm doing the first program for understanding it. Again, switch is there. Okay, switch and LED interfacing, it is there. Okay, you can use it same thing, relay and buzzer. Okay, so I'm using first program. Okay, basic same step you have to use it for your other programs also. Switch I'm writing here. Okay, now you people are able to see this one. 9.
Yes, ma'am.
Okay, now see I'm taking here open new project. Okay, press this one, new project. On the desktop you have created a switch folder, right? So press it, that switch folder here. So desktop, you go to the desktop here. Okay, here I have written at switch. Okay, go to that switch here folder and write down here switch, SWITCH. Okay, and save it. Okay, now here it will be asking you like this. So you take it here, this one device database, you take here. Here you write it down 80, 89, S52, you take it. Okay, now when this database has been created here, okay, use this one. Okay, you take, otherwise you not required this one also. Okay, so yes, now in this one, once this is target is created here, okay, first write down the program. Now go to this one, file new. Okay, type the program over here. So basics, C program only it is, right? So hash include register, in that one you had the header file, right? So I'm taking that header file and adding it in this, everything in this program. So I'll write it here, it is this one. Okay, register 82. Okay, means I'm taking 82 is from 8051 to 8086, the version is same. So I'm taking the version is here 82. Okay, because in that my microcontroller device is having 82 only written. Okay, so here in this one LED is P0 and switch is P1. Okay, negation is pressed here. Whenever my switch, when I am pressing the switch, the LED should glow. Okay, now in this one you have to save this content. So same thing, I have to use it here. Here file name with .c, I have to write it down. So I'll write it SWITCH.c. Okay, save this content. Okay, once this saved, now you have to add here, because the add up in this one, the source group, it has been not yet added. Now that thing also you have to do it, right? So add existing file to the group. So which group? .c file, add it and then close it. Okay, now the steps already you people are writing, I hope so. Now you go to the target, there you press it, options for target options. Okay, here you change the this oscillator frequency, that is you had it 11.059. okay, megahertz of frequency we are using for this one. Okay, now after this we go to the output. Here output, in this one you use it a create hexa. Okay, create hexa file. Okay, once you press it, this create hexa file, after this you go to the listing, debug. Okay, utility is not required, we are also not required. Okay, now once this has been done, press it okay here. Okay, now start compiling with this button. Okay, you will get any kind of error here, it will be displayed on this one. Okay, you people are able to see this one? Yes. Okay, next rebuild this one. Okay, so here you are getting a hexa file to be created. You can see here creating of hexa file will be created in this one. Okay, by using this, which means you are converting your whatever you have run the application, the first compiler, that will be converted in a hexa file. Second one, next in your third compiler, rebuilding it, in that one you are linking that file. Okay, so that linking, once it has been done, so how many data size will be in that program counter, in that how much size it is taking and what kind of object files has been added for creating this hexa file, it will be added here. It will show this something, a code here, code is equal to 25 like that. Okay, so in that code it is storing the data content. Now once it has been done over there, go to this debugger. Okay, Debugger is there here. Debug the session of this program. So start clicking this one. Okay. Say it okay to this one, evaluation mode. It's a stimulation mode actually. Okay. Now in this stimulation mode, you just see here, I'm having this one port 1 and port 0, it's there, right? So you can see here peripherals. Here go to this port 1, port 0, and it is start from which one, LED 0, 0, 0. Okay, first value is 0, 0. Okay, so I'm taking it here, it is value is 0, 0 of that one. Now in this case, either if you are not understanding like this also, you just open the port 0 and start running of your button. Okay, so here port 1 also you open it here. Okay, and here also I'll change it is 0, 0. Okay, now this all are yeah, see this here, glowing of all these LEDs on this one. You can see here port 0 is LED, right? LED is port 0. So all are glowing, means I have pressed the switches of all. Now if I'm making it that switch to be on, okay, so this will be on. Now I'll take it alternate like this. So this will be going off. So just take it that vice versa, it can do it all those things. Okay, switching and LED is glowing it. Okay, come out from that switch, then LED will be off. Okay, on and off. Okay, getting it? I hope so. Now I'm just taking D will be again come back to the D. So it will come to your this one, writing edit mode. Okay, the process should be same thing for all the other programs. Okay, you have any doubts here? Okay, clear with this? Now same thing today we are going to do the other programs also. See, this is a basic program we did, same thing I'm doing it the other programs. Okay, now so in this one I'm opening the other project. Okay, open project. Okay, I've done some programs on this one. The desktop it is there already. I'll take that programs. Okay, see here alternate LED I'm taking it. Okay, so I'll open this one. Okay, see in this one I'm taking P2 is the LED to be glowing it for alternate arrangement. Okay, which is taking it from all the LEDs from 0, 0, 0, means alternate will be arranged at hexadecimal values. Okay, incremented to this one or decremented to AA. Okay, now see in this one I've used here, it is delay for each alternate one pin if it is glowing, it delay by 1000 milliseconds. Again you make the delay of milliseconds, again check it out the other LED. Now same thing if I'm taking it in this one, debug this part. Okay, before that you make the compiling of it. Okay, direct showing because already it is compiled. Now here in this one port 1 P2 is there, right? So go to the port P2 peripherals, here port P2. So once you press it this one, you first change the this one. Okay, so I'm pressing it this one, you can check it out. Alternate LED it is showing it with a delay. Okay, getting it this one, this run button you have to press it, RUN, you can see that. F5 you can use it here. Okay, same thing you do it the other program also. This is your alternate LED. Okay, now ascending order, descending order, two programs are there. Okay, that also the same way you have to do it. Okay, see whenever you're coming to the next lab, so this thing should be done with you people. Install that version of Keli version 5 and do it till programs ascending order, descending order, and this one 7 segment. Okay, 7 segment also, in that one we are giving it all the a 0 1 2 3, that modes counters will be there in that one. Just check it out by using which port number we will be assigning it the values. Okay, so from that you will getting it that. Okay, one more thing, don't write this one. ARM processor LCD, this one. You don't write this one. We'll see this one later on, okay? Okay. 7 segment, I said now this one. We can use it here. See, we had it. This is for location C0. C0 is for what? 0. Next, 0x F9 is 1. 0x A4 is 2. 0x B0 is value for 3. Okay, this all will be stored in your number code register. Okay, that number code register is assigning to P1. Okay, so that will be going to be glowing it for this assigned values. Okay, just we'll check that program. Okay, here I'll open that project, open project. Okay, okay, compile all the things, compilers for exa and for linking. Once this is done, go to the debug one for stimulation part, say it okay to this. Okay, run button is there, you just check it out. Okay, with this one you can check it your program whether it is coming it 0, 1, 2, 3, 4, 5, 6, 7. That all variables are coming it or not, just we'll check it, but till 0. Okay, 7 segment 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Till that it will be executing it. Okay, for each one this will be allocating one values. Okay. Okay. Getting it till here, right? Hexa values. These are all the hexa values now. You people learn in microprocessor lab. I need not to explain again how we are getting it this. Okay. Hexa values it is. Okay. Okay. Now in this one, after this we done this one alternate LED, right? Now same thing you have to do it in your home, ascending order and descending order. If you are getting ascending order, LED -1 you are doing it. Means hexa value -1. Ascending, descending, you just check it, +1 will be there here. Okay. Descending orders. Here minus minus we are writing it here. Here plus plus, I plus plus. Okay. 0 it is starting, you are descending in that 0fx, 0f hexa value. Here descending order, ascending order when you are doing it 0 0 will be there. Okay, increment decrement, that's it. Okay, program is very simple, incrementing and decrementing, that's it. Okay, now mode 4 counter in this one, till mode 4 counter only you show the program, means 0 1 2 3. Okay, like segments, how we are getting it, segments 0 1 2 3, like this. In mode counters also we are having it 0 1 2 3, so we are assigning that from this pins. Okay, from this one we are assigning to this. Okay, so whenever that it has been assigned for the mode counter 4, it will be written as like this. Okay, a percentile b means you are making it that 8. Okay, 8 digits, 8 variables are there here, all 8 values are there here. Okay, because I'm taking it here 0 to 9. Okay, so because 0 1 2 3 4 5 6 7 8 9, right? So but I have to take it from that, which one I have to take it, only the segments of 0 1 2 3 4. That's why I'm doing it here, percentile of a and b. Okay, which is going to get from your c. Okay, store it in a c. Okay, that c variable have written here as an integer variable, so that's storing in p0. Okay, now which are variables I have to store it for, I'm going to check it with d. Okay, so here pins will be assigned here. Okay, 3 4 5. Okay, when you press it 3 4 5, you'll get it there, the pins which you have stored for the mode counter 4. Same thing you do it for your 32-bit LEDs. Now in this 32-bit LED, till now, see, we have seen it over 8 bits are there, right? Like that, we'll be having 16 bits. Okay, so above one is 8, the below one is 8. 8 8 16. Okay, so in that 16 bits and the other 16 bit, total 32 bits. Okay, they'll be glowing it on and off. Okay, when you press this P2, you'll understand this program. Okay, plus 1 will be initiated from 002. You assign all the 32 bits to be glowing it. Yes, glowing it in a binary counter way. Okay, 1 and 0, 1 and 0, 1 and 0, 1 0, like that. Okay. Now till here it will be clear with it. I hope so. Till here you do it in your home. Okay. If you are not getting, then we can try it off here. Okay. All of you clear with this? Then I said last in stepper motor only I have used it 2 pins only to knowing it. Okay. Actually, in your stepper motor we had it clockwise direction, anti-clockwise direction. Some windings are there inside it. Okay. So what it happens? Total in P2 we had 8 bits, right? 4 bits will be other side. The other 4 bits are on the other side. Okay. When it is rotating to the positive direction, okay, rotating on a positive direction, that 4 bits will be glowing. Should glow. Okay. If it is not rotating on the anti-clockwise direction, there will be off state. The other 4 pins will be on state. Okay, so that program it is. You just check this one, stepper motor also. You'll get it this one by using delay. We are writing it. See here, 1, 2, 4, 8. Okay, windings are there. 1, 2, 4, 8. Okay, the other windings, if you want to write the other side also, just write it down here. 10, okay, 12, okay, 14, 16, okay, negative windings. Okay, if you write that also, it will, you are going to get it. See, port number is there, right? This is 4 pins, this is 4 pins, will be having it there. This first 4 pins will be glowing it, the other one 4 pins will be off. Okay, when you do execute this changing it 8, 10 and 12 and 14 and 16, then the other negative windings will be opening it. Okay, that program it is. Okay, stepper motor. Same thing, if you dump the hexa file in your microcontroller kit, the same LEDs will be glowing it. That's it. Okay. Here the same thing we are doing for the elevator also. We'll do this in next class, elevator and your traffic one. One more thing here, external interrupts are there. Okay. So this we will be knowing it when you are, we go for the in-depth of interrupts, what are there. Okay. I said that we had it, timers also we had it, right? Timers are there. Okay, enable interrupt is there, right? So how we are in making that enable to that pin to be interrupt. Okay, whenever the LED is glowing, you show that the interrupt has been occurred. Okay, when the interrupt has been off, you show the other LEDs to be glow. So 0100, that value will be showing it. Okay, that you'll understand when we do this program. Okay, till here you first do it in your home. Try to do it till at least here, binary counter of 32-bit interfacing, so that in the next lab we'll start this stepper motor and elevator and external interrupt and traffic light also. I think so it will be there. Keypad is there. These all are the these are all ADC, DAC is also there. Analog to digital converter, digital to analog converter it is. By using LCD, we are writing that values. Okay. Traffic light is there. Okay, we are using your subroutines over here. You can see that for red light and green light and yellow light. Okay, same thing we are writing that hexadecimal values. Okay, here to functional this part. Okay. Okay, now the same program still here we have to use it in a keel version. Okay, cycle 2 will not use keel over here. We use it over here Xilinx software. Okay, so we do the cycle 2 last. Okay, we first complete the cycle 1 and cycle 3. Okay, cycle 3 again we are going to use it the same keel version only. I'll show one program. Okay, if meanwhile if the classes, if I would have not taken any classes now, you just practice that thing also. Okay, see cycle 3 is there. Okay, same thing we have to use it, the thing, but in this case generally what it happens is real-time applications we are using it. Okay, you are having the task, right? So in round robin example we'll take it. Okay, round robin scheduling, what it happens here, priority wise it is going it, right? Okay, preemptive, non-preemptive, remember, right? So like that we had the different task over here, but we are taking here as LPC 2148 we are taking it. Okay, till now we have done in your cycle 1 8051 microcontroller, right? But in your RTOs we do it all the microprocessor. because it is 32 bit. Okay, now 32 bit we do it in this one 80 LPC 2148. Okay, so that's why we are writing it, all the tasks will be written over there. Okay, here we had the other the values will be initiated here. Okay, for yeah, these are all the hexadecimal values will be there. With that 8 bits are there, so you can check it out, 1 2 3 4 and FX 40. So that dir will be input output, dir will be set for this value. Okay, now input output value for this I will be less than 30. Okay, this will be knowing it in your next classes. Okay, now you clear it, whatever the value, still dir of this values. Okay, so here we are creating how many tasks? We are creating 8 tasks we are creating. So each task will be assigned over here by using OS task create. You people have learned OS, right? Operating system. In this one we required what? PIDs. Remember that IDs will be created over here. Okay, ID1, ID2, like that we had 8 IDs we are creating for 8 tasks. Okay, once we assign this one task to that IDs, okay, then we'll write the loop in this one inside it. Okay, if it is count is 1. Okay, now I'm counting it for task 1. Okay, so what it happens? Okay, wait till this one clear your this one. See the clear we are taking IO clear from FF, last FF. Okay, values. Now here I'm taking the first value of 1. Okay, 1 I'm taking. See, you just take it here, 1 I'm taking it. Same thing I'll take it for 2. IO set for 2. Next I'm taking it, setting it 1 and 2. Okay, again I'm taking it for 4. Okay, okay, again 8. Okay, then again 10, 12. Okay, when I'm taking 12, this will be moving to 20. Okay, so here in this case, when count value, how it is moving it, in that one loop, you have to check it out. Okay, 20. Again going to the first one, 4. See that 4 or 40 I'm getting it means actually I should have it here. I'm getting it stopped here 8. Okay, 0 0 8 0 0 0 here. But in this case, what I'm getting it here like this 1 0 0 0. But actually I used to have it here 1, right? But here it has been flipped because count I'm taking it by divided by 2, multiple of 2, right? Here now I'm taking it again in a location of 20. Okay, check it out, this 20. Then again 40. This one 40 we are getting for the next one. Again 80 if you are taking 80 like this. Okay, so 8 loops will be 8 tasks will be created like this. Okay, and same thing, we are clearing it and then counting plus plus. Okay, wait for 120 seconds. Same thing we are using it, same copied this one in that version, and only the thing over there you have to use it is, I'll just show it in a Keel version. That I'll open it, open project of E drive. I had it rtos. I'll just, if possible, I'll send this all zip file to you people, so you can do it in your home. Okay, taking at the same timing program here. I'll just check it out. Open, click it here, so you'll get the all the programs here. Same thing which we have just now explained it. Okay. Now, last main system of this system, initial tasks ones, you have to read it from here. Now, I'll take it the same thing here. Just check it the options for target option. It should be selected here. It is RTX kernel. Okay, we had it for the above the cycle 1 programs. We used to had it OSS none. We will take it. Okay, and use it here. Use microlib. Okay, and then after this you had the outputs. Create the hexa file. You have to click it this part. And one more thing, command you have to right click here. It is use memory layout from target dialog. From the target dialog only you have to select it. Okay. Now here utilities, you go to this one, path location for your exe file. Okay. Now in this exe file I'm having LPC 2148. Okay, ISV version is there. Now here you can see in this one, take it okay for this part. Click it here. Same thing you do it here. Go to the debug session over here. Hit okay, you'll get like this. Okay, now in this one you will be having it peripherals, we had it GPI. Okay, go to any port one here. Okay, and start running this part. Okay, general purpose input output. Okay, first fast also you can take it, or slow also you can take it, otherwise I'll take fast. Port 0, which port it has been initiated. Port is not initiated. See the port 1, it has been initiated. You just check it that dir I am having. So first I am taking it 0 f0 ff, right? So the pins how it is moving, check it out. See, you can observe here. Okay, same thing I'm having it. I'll check with the OS also. So go to here, debug one, we had OS support. You can see that in that one you just click it, system and threat viewer. In this one you can see the values how it is moving. See, you can see here. I'll just drag this part. You people are able to see this one, ma? Able to see this one? System and thread viewer. I'm not getting. Say yes. Yes. Okay, 33. Now, see, you can see here real-time operating system, which is going to be moving it along with the task. Okay. You can see here delay, it is taking it. Wait, delay. Task 1. Like that, I'm having it till task 8. See, task 8. Okay, so how it is moving it, this one also your GP general purpose IO also moving, this is your output. Okay, these two things you have to make it and save it. Same thing till now, whatever the programs we are doing now, this debug session you press it. Okay, check that pin, and this OS one won't be there for your cycle 1, but cycle 1 you will be having ports. Okay, now in your cycle 3 we had GPI. Okay, general purpose IOs we had it, and OS also you have to check it because we are checking the task. Okay, whether in an ideal state, running state, what state they are. Okay, this one is your output. So you take the screenshot of this thing and take the screenshots of the above cycle 1 programs also. That is your output, which you have to paste it in your records. Clear this one, all of you? Any doubts here? 33, 9, 9. Okay, I'll check now. I'm going to check it out. How many people will try this one, all programs? Next week, you have to execute all the programs of cycle 1 till 32-bit interfacing. Okay, if you are done with that, then only join to the lab, otherwise not required. Okay, and this RTOS program, in if possible, I'll send you all these programs to you people so that you can write it down in your see, you can execute these programs in your kill version 5. Okay, but see here, one thing I'm going to tell you this regarding this. See here, you have to write it in your, whenever the exam is there, for if you're getting cycle 3 is your program, for example, timing program you got it, you have to write down this one, this program you have to write it down. Right. Where is this timing.c, you have to write it down. Just know which one we have explained you, na? That thing you have to write down. From here to here, you have to write it down. Not required this rtx config file, you not required to write it down. Startup.c also not required to write it down. Only timing program only you have to write it down. So only in your examination this file will be there, folder will be created outside. You have to just type it, this one timing.c, in that you have to save it and run it your program. Got it, this one? All of you clear with this? Yes. Same procedure is there for the rest of the programs also. See here we had the other, you people are able to see this one Word file 9.
Yes, ma'am.
So
Yes.
in this one, see same procedure is there for this rest of the program. Signals, round robin, semaphore, same procedure is there. Just check it that create hexa is there, rtx kernel has been selected or not, just check it that, and microlib you have to press it okay, and you will get like this. Okay, you have to just take the printout of snapshot of GPIO and this system thread event. Okay, which is running, going on running, no, that one. That's it. Okay, got it. This one lab cycle 3 also clear with this. Yes, all the programs still here will be a same procedure. Okay. Okay, I'll take the attendance and then you can leave after that. Yes. Yes, just answer your attendance, ma.
Roll number 9.
9,
Roll number 33.
33, 60, 9, 33, 27. Are you there, 27? There is no response from 27. Okay. Clear with this today's class? All of you? 33, any doubts, ma?